Eric Darling here with Darling Data, and in the interest of fiscal solvency, we're going to talk about building reusable queues. What does one have to do with the other? Absolutely nothing. I just blurted that out and went with it. And I don't feel like starting this thing over. So you're going to just have to cope with that mentally somehow. So there are two aspects to building. I mean, there are a lot of reasons for building queuing processes in SQL Server. And there are all sorts of different ways to do it. There's like first in, first out. There's, first, last in, FIFO, LIFO, FAFO, last in, first out. I'm gonna skip over the third one. And there are all sorts of different ways you can choose to dequeue something. And by dequeue, I don't mean Dairy Queen. I mean to remove something from eligibility for queuing. For me personally, it really does depend on why I am the intent of the queue. There are times when I would want to, just delete something from a table when I have started processing it. That's a completely legitimate way to do it. And in this example, I'm just updating stuff. And sometimes the update thing is nice because rather than just delete an item from a queue table, you can have the queue table retain some information about the queuing process, right? So it's like you can have some generally useful stuff in there, and so that's the way that I kind of like to do it. And you can kind of see that in the setup of my queue table here. So I am going to do what every good little SQL Server DBA does, and I'm going to have an ID column. Mine's going to be a bigint because I believe strongly in using bigints as for identity columns. The process of having to fix that is a real nightmare, and I wish Microsoft would make it less of a nightmare. To me, that's a pretty major scalability issue that they just ignore. And what do you call it there? Yeah, I'm saying for domains, things that you understand can never go past a certain number, dispositions of things, concepts of the Stack Overflow database, vote types or post types. You can never hit over 2 billion types of posts. You might hit over 2 billion posts. That'd be a lot of posts. That'd be a lot of questions, but you're never going to have more than an integer's amount of types of posts. So when I'm making a table with an identity column, I'm gonna suck it up and use those 4 extra bytes. Oh my God, the 4 extra bytes. And I'm gonna use a bigint because it's the funny thing to me is that when you start talking about data types, you have the absolute worst people on earth will start talking to you about bytes, and especially when you talk about ints and bigints, they're like, well, integers are 4 bytes, bigints are 8 bytes, disk. I'm like, well, okay, fine, it is legitimate. The thing is, at about the point where you're going to start maybe caring about the 4 extra bytes that you're storing is probably going to be right about the time that you're starting to run out of integers. And when you have those 4 extra bytes is available to you in bigint form, you're going to be so much happier that you don't have to fix that problem. So, that's my thing right there. So for this queue table, since we're not doing a delete queue, we're doing an update queue. We need a column like this to tell queries when a row is being processed. In this case, the thing that I'm using for the processing point is just the reputation column from the users table. It's really just completely senseless. And then I have some. This is what I was talking about, where I said it's nice to have some information about how long it took to process a thing. So what we have is a couple, 3 columns in total: a start date, an end date, and a computed column that calculates the duration in milliseconds between the start date and end date. I'm using milliseconds here because this particular queue would process very quickly, but in real life you might want to do seconds or minutes or something to get more human understandable numbers out of it. And then the two important things are for processing this Q table. This one probably the most important, because what we need here is which will make more sense when we look at the queries that actually hit the table. What we need here is a really efficient way to find things that are not being processed, or skip over things that are being processed, and a way to order the results after that in a way that we can process the queue in order. If we were going to process these things differently, for example, the lovely, talented Canadian Aaron Bertrand, just Canadian Bertrand is going to be his name from now on, has a series of posts about snake sorting. And snake sorting is a way sort of a way to divvy up work equally amongst threads, so they all sort of finish around the same time. The context of his post was like distributing backups to threads, so like you wouldn't have one thread, oh, I got an 8 terabyte backup, oh, now I got a 10 terabyte backup. They would be like, I got an 8 terabyte backup, now you take that 10 terabyte backup, and the other 2 threads, you take like the 4 terabyte backups, and we'll all chug through these things more equally. So if you have that kind of knowledge about like the size of a process, or the size of a thing that has to be written, you might not want to do something as naive as just say, like, just give me the next one in sequential ID order. You might want to like use some additional logic, like Aaron does, to split things up to make the thread, each thread do a more fair amount of work. So depends on how you're dealing with that stuff. So here's the store procedure that this sort of a template store procedure that I use to run the queues. And it's just a perpetual loop until we run out of work. So, something that's pretty important in here, I'm going to split this up into 2 parts. The locking hints in here are particularly important regardless of which isolation level you're in, because if you're using, just like option wise, if you're using read commit, just really if you're using pessimistic versus optimistic, if you're using a pessimistic isolation level like read committed, you're gonna have a blocking nightmare if you don't put stuff like this in, right? And if you're using an optimistic isolation level, you're going to have a pretty hard time with a time of things if you don't add in some additional locking, so that like, in some cases, like you're going to want read queries to not see version data. So you have to be careful with that. If you are using an optimistic isolation level, you will probably want to use the read committed lock hint for queuing processes. That goes for queuing processes, or if you're doing anything like building a sequence table. Paul White has an excellent article on building sequence tables where he uses the read committed lock to great effect in there. And I think that's probably something that you would want in a queuing process like this if you were using an optimistic isolation level. And if you are a good little data darling out there in data land, and you are being real smart, you are using an optimistic isolation level, because pessimistic isolation levels are the turds. They are nothing but problems. So, yep, there we go. And you know what? I accidentally deleted something in here that I shouldn't have deleted. I just realized it now because I saw some red squiggles. That ID integer. No. Reputation. Sorry about that. Integer equals no. Oh, that should be no. Like that. And then so what this code does is it'll look for things that it needs to process, right? So while we have at least one row in the table that needs processing, we'll enter a loop that looks like this. And this is where the index thing makes a little bit more sense. So we're going to use a common table expression here just because it's a little bit cleaner than using a subquery or any really. If we could use a derived table here and it would be the exact same thing. But for this, it just kind of it does make the sort procedure a little bit more readable when I use a common table expression here. So what we're going to do is just select the top one row, and we're going to hold on to that one row. We're going to say row lock up D lock, and we're going to hang on to that one row, and we're going to, again, like I said, this is just very naive sorting to just get me the next available thing in sequential order. You might need to do this a little bit differently depending on what your process is. And then we're going to use kind of a neat thing where we're going to use an update to not only set a couple columns in the table equal to something. So this update will start by changing in the in-process column to 1 for whatever row that we find, and it will also update the start date to the time that we started this, so that when we're done at the end, we can add we can update the end date column so we know how long something took. And then we're going to do something that I think is particularly clever. We are going to, in the same update, we are going to update our two parameters to be equal to the columns in the Q table that we found up here for the one row that we pulled out up here. We're going to set those equal to the column values that we pulled out there. Then, just what we're going to do is we're going to use those as part of our queue process thing. My pretend example is just selecting a count from the users table where reputation equals whatever reputation we pulled out there, and we execute that SQL down there, and then we use the ID column that we fetched. If this Zoom it will listen to me. Zoom it will ever listen to me. I'm hitting escape like every 3 seconds, and Zoom it is just like, I don't care. Come on, Zoomy. There we go. All right, that took a little bit more wrestling than I cared to do. And then the final thing that we'll do down here is update the Q table to just set the end date to when this thing finishes, and the ID equals the ID of the Q item that we pulled out, and that will be really quick. There's also just a little safeguard there to make sure that we would only ever update a row that's in process and not a row that is not yet being processed. Even though that's sort of technically impossible with this, I just like to be extra safe when I'm running these things, when I'm automating tasks like this, because if you're not, you can run into some really weird bugs. So all of the code and a somewhat deeper explanation of some of these things is available on my blog. There are 2 posts that'll be in the show notes, as they say, about building reusable queues. I originally wrote it as a 2-part series. I forget why. Probably because I needed an extra day of blogging to cover something. It's hard to tell sometimes, but I think it's a very interesting problem when you have to tackle this sort of thing, and doing it correctly and doing it in a way that is effective for high concurrency and not having a bunch of awful blocking problems is especially interesting. And that's where table design is really important, and making sure that your table is set up in a way that allows you to find the rows that you need to process in the order you need to process them as efficiently as possible. So like, if you're doing something where there's going to be like, 4 or 5 worker threads, and they're going to like chug along on like huge tasks for a long time and then come back, the locking and blocking thing probably isn't going to be all that important. But if you need to orchestrate like really high concurrency queuing and distribute those queues without running into a blocking nightmare, that's where this kind of stuff becomes much more important. So anyway, thank you, especially you, the good looking one sitting right there, for watching. I appreciate you more than words could ever possibly describe. I hope you enjoyed yourselves a little bit. I hope you learned something. If you like this video, thumbs ups and helpful comments are always nice. I do enjoy those. If you like this sort of SQL Server content, please subscribe to my channel. You can join the nearly 4,000 other data darlings out there in YouTube land who have done that, and who make me feel like a special, helpful, useful, good person by allowing little bells to go off in their head every time I publish a video. So yeah, you can like and you can subscribe. You can do the both, and then you're extra data darlingy. And I owe you a hug. So anyway, I got some more of these to record. I got to bulk up things before I go away for a little bit. So this one's getting canned right about here. Thank you.